let's talk about another way of thinking of multiplying vectors. This is the cross product. Not to be confused with the dot product. So the cross product, let's just say vectors A and B we're trying to take the cross product of, represented by the multiplication sign, like so. And this we can describe as magnitude of A times the magnitude of B times the sine of the angle between them. Now if you think back to our definition of the dot product, that was the cosine of the angle between them, which basically said the component of one vector parallel to the first vector. This one, as you might expect, the cross product describes the component of one vector perpendicular to the other vector. What exactly does that look like? So if I refer back to the dot product notes, try to make something similar. Let's set up our Cartesian coordinate system. Let's introduce some vector A. Let's put it down here. Some vector B. Say that we want to take the cross product of these two vectors. So basically what we're saying is we want the component of B that is perpendicular to A, and we want to multiply that by A. So as before, we can take and dissolve B into components. So we have B sub y and B sub x. But in this case, B sub x doesn't matter because it is parallel to A. We want the component that is perpendicular to A. And then we can simply multiply that by A. So if we took, let's just move them over here, B sub y, B sub y, so B, multiply that by vector A, and we multiply them, we will get this right there. And this is AB sine theta. Now you might be asking, wait, where is the actual vector? Where does it point? What is the direction of this resulting vector? And this is where things get a little bit complicated. It's actually very simple, but it seems quite complicated. The cross product of two vectors is perpendicular to them both. Now what do I mean by that? It means that in order to be perpendicular to them both, this vector must be on the third dimension. So if we're using x and y, this resulting vector will be on the z dimension. So let's say that this is x, this is y. Because if you think about it, the z dimension is perpendicular to the y and to the x. Now this might not make very much sense, but just bear with me here. So basically, the resulting vector projects somewhere along the third axis. What way does it go? Does it go in the positive z direction, the negative z direction? How do we know? And a convention that has been established to describe the direction of this resulting vector is called the right-hand rule. The right-hand rule is an extremely important concept that will be returned to over and over again. And it is relatively simple. It's just kind of complicated to grasp initially. Basically, when you're evaluating using the right-hand rule, you take the first vector, which is A. You point your right hand in the direction of A. It must be your right hand, not your left hand. And then you rotate your right hand in the direction of B. So from A to B. You can curl your fingers towards B. And the direction your thumb sticks is the direction of the resultant. So in this case, my thumb goes from A to B sub y, sticks in the direction of positive z. So we could say the resulting vector, or shouldn't call it the resulting vector, I should call it the solution of the cross product pointed in the positive z dimension. Now, this concept might seem ridiculous and arbitrary, but it actually has great implications when we talk about other concepts like torque. Say that you're spinning a doorknob. It has to spin about an axis. So in this case, it's spinning about the axis of z. And that is projected, in this case, positive. Now, is it always positive? Of course not. Say that instead B sub y was facing downwards, and we face our right hand in the direction of A, curl our fingers downward towards B, and now the thumb sticks into the page. So that would mean that z would be pointed on the negative z-axis. So from this, you might be able to guess the cross product definitely matters which one comes first. Because if we were to do B first, B cross A, then we would get a different answer than A cross B. So the order in which you take the cross product is very important. And that's pretty much it for the cross product. It will be definitely come up just like the dot product on a lot of other concepts later.